Hi, it's Mr. Anderson here. I'm going to go through FP4 January 2010 question 6 today. This question starts off with two planes in vector form, and it asks me to find the p-value, and you can see the p here is, let me just change to yellow. So this one here contains the p-values when the planes are perpendicular and parallel, and when p is 4, we want the Cartesian equation of each plane. We are looking for the line of intersection of the planes, and we're also looking for the plane in which that line lies. So let's start off with the perpendicular condition. Well, these two vectors, 6, negative 3, 2, and 4p plus 1, p minus 2, and 1, those two vectors are actually perpendicular to the planes. But it's okay to use the perpendiculars because they behave in the same way as the planes with regard to these two questions. So let's start with the perpendicular condition to begin with. The planes are perpendicular if the dot product of those two perpendicular vectors is 0. And the reason for this is because the dot product definition contains cos theta, and cos theta is 0 when the planes are perpendicular, when theta is pi by 2 or 90 degrees. So all I need to do is set the dot product to be 0 and work out the p-value. Multiplying the top two numbers, the middle and the bottom gives me p is negative 2/3. That's fairly straightforward. The second part of the question is also to do with these two direction vectors, but in this case we're looking for where the planes are parallel. So that is the direction of one is a multiple of the direction of another. So I've set the parameter, if you will, to be x, and I'm going to solve this to find the x value. And the bottom row is the real giveaway here, because 2 is equal to x times 1, so x has to be 2. And then I can plug that into the top row, giving me 6 is equal to, here look, 8. P plus 2, so the p-value is 1/2, and I can use that p-value on the middle row just to make sure that the planes are indeed parallel, and it works. Now we've moved on to the second part of the question. We're looking here for the Cartesian equation of each plane, which is just a matter of replacing r with x, y, z here. So x, y, z multiplied by or dotted with 6, negative 3, 2 gives us this top equation, and the second equation comes from substituting p equals 4 into the plane we are given. So here are my two Cartesian equations. And what we're going to do now is find in the form r equals a plus lambda d, the line of intersection. And in order to do that, I need to remind myself about this form. R is any point x, y, z on the line. A is a specific point on the line. Lambda is just some number that enables you to move up and down the line. And d is a vector in the direction of the line. So in this case, I want to know the direction of this line here. I want to know the direction of this line of intersection. And I do that using the vector product. I've attempted here to draw the two planes from the question, and I've marked on the two perpendiculars, and you can see them nicely in this diagram. The vector product of those two perpendiculars is this arrow here, and you can see that this arrow is in the same direction as the line of intersection of the two planes. So if I could calculate this cross product, I would know the direction of the required line. And that's what I've done here. I've calculated the cross product. The negative 7 coming from the bottom four numbers, the 28 coming from the top row and the bottom row, remembering to change the sign there, and the 63 there coming from the top four numbers. And the vector product there is complete. Although I just want the direction of that line. I'm not bothered about the size of the vector, so I've simplified by dividing by 7. So here's the direction of the line. It only remains now to find a particular point on that line, and the easiest way to do that is to set z to be, or set anything to be 0, but set z to be 0. So you set the z coordinate to be 0 and work out what's happening in the xy direction. So if z is 0, then the two Cartesian equations simplify to this pair here, which are much more straightforward because we've just got two letters. So using row operations, I can calculate x as 1 and negative 12. And this gives me the point 1, negative 12, 0, which is a point on the line, and this enables me to finish the question now. Here is my point, and here is my direction, and that's complete. And finally, the question asks me to determine a vector equation in the form r equals, that is u plus beta v plus gamma w for the plane which contains the L and which passes through the point 730. So here is such a plane. We can see L within the plane, and the direction of L being negative 149, the direction of this line here. this 1, negative 12, 0, this is the point that I calculated to be on the line, and the point 3730 of Mr. Brackett there is a point on the plane. So what I need to do here is calculate the direction of two non-parallel vectors within the plane and also a particular point on the plane. So the working here comes from finding, you see the dotted line here, finding the direction of that dotted line. So as 3730 is the position vector of this point, and 1, negative 12, 0 is the position vector of this point, if I do a subtraction, this gives me 29, 19, 30, and what this is the direction of the dotted line that lies within the plane. And then I can finish by writing down the equation of that plane. 1, negative 12, 0 is a particular point on the plane, plus beta lots of negative 149, that's one of the directions within the plane, and 29, 19, 30, that's the second one there that I've just calculated. Okay, I hope that video has been useful. Thanks, bye-bye.